Imagine you want to investigate a hostile planet 42 million kilometers from Earth, with an average temperature of 460 degrees Celsius and an atmospheric pressure at 91 times higher than Earth. These harsh environments make it impossible for mankind to even set foot on the planet's surface, but not for a robot. A highly sophisticated Arduino-controlled ultrasound-guided robot is able to withstand the scrutiny for a mere 8 minutes. There are these 8 minutes that are vital to collect rock samples in order to get a better understanding of our solar system and maybe even the origin of life.
The mission aims to find several different rock samples that are hidden across the planet. Each sample must be collected and analyzed at the lab. At the base camp, the rock samples have to be assembled and placed inside the rock analysis laboratory.
Using 7 phototransistors combined with 22 infrared LEDs located on the front of the gripper, inside the gripper and in front of the wheels, the robot is able to detect and align itself with rock samples up to 6 centimeters. Using two CY70s, a compact combination of an IR LED and a photosensitive transistor, located on the right and left side of the robot, we can detect the amount of light reflected by the surface on which the robot drives. This information gives us the ability to stop and change direction of the robot when it detects a crater on Venus' surface. On top of the robot, a sonar is mounted that is able to rotate 180 degrees. It uses the time it takes sound to travel to and from an object to determine the distance from it. With this information, it knows when an object, for instance a mountain, is too close to the robot. It will stop, look for the longest distance it can find, and in that direction it will travel. The base uses an extra Arduino and 2 transistors to create a set of blinking infrared LEDs. The frequency of the blinking will allow the robot to know which side of the base it is. It is then able to drive towards the entrance to return a rock sample. The final thing a robot still needs to be able to do is to return to its base when a rock sample is detected. Hidden behind each wheel is an encoder that is able to tell if a spoke has passed. Using this information, the robot can remember its position relative to the starting point, in our case the base. It will calculate the distance from the base and the angle it needs to turn. It will then drive back to the base in a straight line.